So Lindsay Allen is a climate resilience engineer in CBCL St. John's, Newfoundland and Labrador office. She specializes in climate change risk assessment and adaptation planning to support a wide variety of industry sectors, including transportation, natural resources, new and existing infrastructure, and municipal planning. She has extensive experience in facilitating stakeholder consultation and is passionate about incorporating local perspectives and expertise in climate risk assessment and adaptation planning to develop practical and innovative solutions. Throughout her career, Lindsay has worked in a variety of fields, including geotechnical and environmental engineering, contaminated sites investigation, mining, oil and gas, and government, allowing her to bring a wide variety of knowledge and depth to her risk assessment work. And so we're very happy that Lindsay's made time to talk to us today, and I'll pass it over to her.
Thank you very much, Dan. Very happy to be here. So like Dan said, I am in St. John's, Newfoundland. So before I start, I would like to respectfully acknowledge the territory where I'm presenting from today as the ancestral homelands of the Beothuk, and the island of Newfoundland as the ancestral homelands of the Mi'kmaq and Beothuk. I would also like to recognize the Inuit of Nunatsiavut and Nunatsiavut as the Innu of Nitassinan and their ancestors as the original people of Labrador. So like Dan said, today I'm here to present on a climate risk assessment using the PIEVC high-level screening guide that we are doing at CBCL for bridge infrastructure in Ontario. So this project is for the federal government. Before I start, I do just want to point out that this project is a confidential project, so I can't get into really specific details on the infrastructure and locations and things like that. But basically, what I'm here to present on today is just a fairly straightforward case study on how the high-level screening guide can be used to assess risk to infrastructure. So next slide, please. So a little bit of background on the project. So as some of you may know, the federal government of Canada has some various targets and goals related to incorporating climate resilience into their real property assets. So that's really where this project stems from. So basically, PSPC, Public Services and Procurement Canada, engaged CBCL to conduct climate change risk assessment for 3 bridges in Ontario to inform their ongoing operations, any future upgrades they may have planned, and just general long-term planning and asset management. So we're looking at 3 bridge sites throughout Ontario and 3 different types of bridges. So one site is your typical, lift bridge. The deck of the bridge just moves vertically up and down. The second site is what we call a bascule bridge. So a bridge that sort of rotates on a hinge at one end to let marine traffic through. And one is a more typical span bridge, just a metal truss bridge, no movement involved. And what's interesting about this project and the application of the high-level screening guide to this project is that each of the sites consist of multiple assets. So there are the bridges themselves, there are buildings, there are electrical, mechanical equipment, lots of different things to consider here. So it's a great application to include all of those things to inform asset management from a high-level perspective. Next slide, please. So basically, like I said, I'm just going to walk you through the application of the high-level screening guide for this project. So we followed the steps of the high-level screening guide pretty closely. I will also say that the project isn't quite finished. We're currently in the recommendations of reporting phase. So I will sort of speak to what we've done so far, but step 1 was essentially the scoping part of the assessment. So that's where we just tried to break down the assets, figure out how we wanted to group things and score things at each site. Step 2, the climate analysis and impact assessment. So that's where we get into likelihood scoring and characterizing our assets. Step 3 is the actual risk assessment. So finalizing the severity scores and calculating our overall risk profile. And then step 4, like I said, that's where we are right now, recommendations and reporting. And of course, the overall goal is to sort of complete the formula below, identify which which assets are exposed to a climate hazard, the probability of those climate events or hazards occurring, and of course, the severity of potential impacts. All that comes together to calculate your overall risk. Next slide, please. So I'll dive into each of the steps a little bit. So like I said, 3 bridge sites located throughout Ontario, that's the main focus of the project. And each site can be sort of described as a portfolio of assets. So at each site, we have the main bridge itself. We have coastal infrastructure such as wharves and guide walls that direct marine traffic. We have supporting buildings, whether it be offices or warehouses, electrical and mechanical equipment that support backup power or the actual lift function of the bridges. And then something interesting about one of the sites that we're looking at, we're also including contaminated sites as its own sort of asset. So in this case, we're looking at the different contaminants that are present from a historical contaminated site, and looking at how various parameters, climate parameters, could impact future migration or changes in concentration of the contaminants that exist there. So like I said, a very wide portfolio of assets. So one of the first steps was to sort of break that down and figure out how we wanted to divide the assets for scoring purposes. And I'll show you a little bit more into that on the next slide. So something else that's a little bit unique about this this project is that because there are so many assets, we have a number of different stakeholders to deal with. So PSPC themselves, as well as other government departments such as Department of Fisheries and Oceans and Environment Canada, specifically as it relates to the contaminated sites portion. And as well, our team internally at CBCL is quite large, and we have a lot of different disciplines involved. So the risk assessment specialist, that's myself in this case, as well as a couple other risk assessment professionals. We have a few climate specialists on the team to actually do the projections. And then we have subject matter experts from a bunch of different disciplines. So structural, civil, bridge engineering, mechanical and electrical specialists, coastal specialists, contaminated sites specialists. We have a ton of different people on our team so that everybody can really evaluate those risks appropriately. Next slide, please. So like I said, sort of the first, I guess, phase of the first step of this project was to figure out how we wanted to separate our assets here. So it's maybe a little bit hard to read here on the right, but essentially we took each individual site and we broke it down into its key assets. So in this example, we have Bridge Site 1. We broke that down into marine structures, the actual lift bridge itself. In this case, we had a couple of additional smaller concrete bridges that support sort of a full causeway system. Like I said, we had some buildings, and then we grouped just general site features together, such as traffic control systems, civil systems like drainage features, for example, emergency power. So you can see under each of those main asset categories, we then broke those down into different elements. So the different wharves we're looking at, guide walls, abutments, all of those under the marine structure. Under buildings, we have the buildings separated out. And then even further to that, it doesn't quite fit on the slide here, but we broke each of those elements down into sub-elements for scoring. So that's where things like the electrical mechanical systems of the building come into play, or the electrical mechanical systems of the bridge, or of course, there's different components to the bridge, such as the deck and various other elements. So each of those things are broken down even further for the scoring. Not part of the assessment. Also in step 1 in this scoping phase, in my opinion, one of the most important steps at this phase is to really define your performance response factors. So that's the type of impacts essentially that we're going to be assessing for this project. And that can vary from project to project, depending on the needs of your client. So in this case, we looked at a bunch of different things. So we're looking at potential structural impacts, impacts to operations, so day-to-day operations of the bridges, economic impacts, as well as impacts to health and safety and regulatory impacts. So there were a lot of different things to consider here. Again, it's very project specific. In some cases, we'll just look at one element, maybe just structural components. or health and safety, but in a lot of cases, we do look at a real variety of performance response factors. And again, this is where the high-level screening guide comes into play. You can, when things are assessed at sort of a higher level, you're able to dive into more of these performance response factors and assess a real variety of things. And lastly, in the scoping phase, we assigned our time horizon. So in this case, we have, of course, the baseline period, the 2030s, 2050s, and 2080s. So of course, this is transportation infrastructure, so it's expected to be around for a long time. So that's why we're looking well into the future. But like I said, because there are so many different assets and components and elements at this site, we also want to look at incremental time horizons to make sure we can capture the lifespan of all of these different elements. So some elements have a life cycle of maybe 15 or 20 years before they're replaced, whereas other elements may be 50 or more years. So those time horizons cover all of those things. Next slide, please. So step 2 is the climate and impacts step. So this is where we dive a little bit more into the details. So first of all, we do our data gathering to characterize assets. So each of those assets and elements and sub-elements that I spoke to earlier, we look at background data that's provided by the client or through research to understand those assets. And what we're looking for there is things like thresholds, or any other operational parameters that we can use to define what climate parameters we want to look at. So in this case, we looked at engineering drawings and reports, life cycle analysis, planned upgrade, any plans for upgrades, feasibility studies, options analysis, a bunch of different background documents. Anywhere where there were a few instances where we were missing some data. So to supplement that or to fill those in the gaps, we conducted a site visit to each of the bridges and we developed questionnaires to send to the actual bridge operators to get their perspective from sort of their day-to-day operations and the people on the ground. So then we move into the climate analysis, and this is where that exposure element of the PIEVC process and calculation comes into play. So what we did here was we identified the relevant parameters. Like I said, that was just through having a general understanding of the climate region, as well as understanding the performance thresholds of the bridges. So for example, if the bridge is only able to lift in winds greater than 80 kilometers per hour, or less, that could be a performance threshold that we might look at. We might evaluate that climate parameter. And then we go through each of the climate parameters that are relevant and we sort of assign interactions. So we determine which assets could potentially be exposed to a particular climate parameter, and any climate parameters that have that exposure element for one or more assets, we move forward with projections and likelihood scoring. Next slide, please. So just at a high level, these are sort of the 4 categories of parameters that we're looking at. So we have parameters related to precipitation, water levels, winds, temperature, and as well as some combination events. So those are things like wind-driven rain, hurricanes, rainfall and freeze. Those things where more than one climate process comes into play. Next slide. And just a high level overview of some of the impacts that we looked at. We looked at things like flooding, pressure imbalances, corrosion, potential operational disruptions, so short and long-term closures. I won't go into all of them, but like I said, something that was kind of consistent across most of the categories was contaminant migration or transport, and power outages was another big one that we looked at throughout all these different parameters. Next slide. So to conduct our likelihood scoring, we used primarily the middle baseline approach that the PIEVC high-level screening guide outlines. I won't get into it too much, but essentially that's a process that we use for most climate parameters. In some cases where we had, say, return period data, we did develop sort of accompanying scales that would be based on return period data. So for example, we would look at the 1 in 100 year rainfall event and look at how that might change and become something more like the 1 in 50 or the 1 in 20 or something like that in the future. And we would assign likelihood scores accordingly based on that. And most of our data came from either climatedata.ca, Environment Canada, literature review, or one particular report we use quite frequently is this Canon report from 2020 that discusses climate change for built infrastructure. Next slide. Step 3, this is the actual risk assessment component. So this is where we dive into the actual scoring and communicating with operators to make sure our scores are correct, our consequence scores or severity scores. So in this case, we had our preliminary scores assigned prior to hosting a series of workshops with the bridge operators. And we used the workshops to confirm those scores, get input from the operators to make sure that everything was, everybody was sort of on the same page. And what we did, the PIEVC high-level screening guide, of course, outlines sort of a 1 to 5 scale that gives you a lot of flexibility in how you want to use it. So what we did was essentially took each of our performance response factors. So you can see across the top of the table there, we have operations, structural integrity, financial, and we sort of assign different impacts under each of those performance response factors into the 1 to 5 scale to help us facilitate that discussion and assign scores in the workshops. And after that, it was pretty straightforward to just calculate your overall risk profile. Again, I can't show that here today, but that was the next step. And then anything that is falls sort of within that moderate to high risk category moves forward for recommendations. So next slide. So like I said, this is the phase we are at right now. Anything with a score of 10 and above, we will consider for developing recommendations for adaptation. So some of the potential types of recommendations that we might be looking at are specific infrastructure upgrades, modifications to operational plans, potentially scheduled monitoring, cyclical maintenance schedules, changes to emergency planning or development of emergency planning, and implementing communication protocols between all the relevant parties to make sure everybody's on the same page. And I believe that is it. Next slide. That's all. Thank you very much.
Great. Thank you very much, Lindsay.